All right, guys. Today is a quick review on what we did on Friday regarding translation of the parabola from the vertex from the origin to left or right. And so we had these graphs on the board on Friday. And remember, f of x equals x squared, right? That is the parent function, and the black graph is the corresponding parent graph for the function. And so on Friday, we talk about translating the graph to the right or shifting the graph 5 units. And that's the red graph right here. And we also talk about how the equation is going to change. The For the parent graph, the equation is f of x is equal to x squared. When you shift the graph to the right, to the red, right, the equation now is f of x is equal to x minus 5 squared. And if we shift it to the left now, okay, the equation becomes f of x is equal to x plus 5 squared. So those are the two more things we talked about on Friday. And also we talk about the axis of symmetry. For the parent graph, the black graph, the vertex is 0, 0, right? Because that's the point. That is the lowest point on the graph in this case. And for the red graph, after they shift it to the right, the vertex is now 5 comma 0. So you notice the only thing that changed from the black graph to the red graph for the vertex is just the x coordinate, right? It went from 0 to 5. And for the blue graph, the vertex is now negative 5 comma 0. All right. We also looked at the axis of symmetry. That's a line that splits the graph in two equal halves, and it goes through the vertex. You got to remember that the axis of symmetry goes through the vertex. And so for the black graph, the axis of symmetry is x equals 0 because it crosses the x-axis at 0, the origin. For the red graph now, the axis of symmetry, right, would go through would cross the x-axis at 5 right here. So the equation would be x equals 5. And you notice it's the same value as the x coordinate of the vertex. Now look at the blue graph now. If I draw a line straight down through the vertex, right, it's going to cross x-axis at negative 5. Therefore, the equation for the axis of symmetry is x equals negative 5. And again, if you notice, it is the same value as the x coordinate of the vertex. All right. So a couple things we talked about on Friday, and also if you flip or if you reflect the black graph over the x-axis, which becomes the green graph. Now the equation is just negative x squared, negative 1x squared. All right. We also looked at the the vertex equation of the quadratic form, right? It is f of x is equal to a times x minus h squared plus k. And we talk about what each term means. The k, that's constant. It tells you if the graph goes up or down on the graph. So if k is positive, the graph goes up, and if k is negative, the graph goes down. And x minus h now, that's the term inside the parentheses, all right? If it tells you if the graph translates left or right on the x-axis. So if there's a positive sign inside the parentheses, right? If h is positive, then the graph translates to the left. If h is negative, then it translates to the right. I'm going to look at some examples of that. And then we also looked at the vertex. All right. I can tell the vertex from this equation. The vertex is HK, where H is the X uh, coordinate and K is the Y coordinate. And I'm going to look at an example for that. Let's look at this one. We have the equation f of x is equal to x minus 5 squared plus 2. Okay. Now I can tell just from the equation what the vertex is. Remember, this 5 will be the x value of the vertex. The 2 will be the y value of the vertex. So when you get the vertex from the equation, you've got to change the sign of the k of the h. Here it is -5. It now becomes +5 for the vertex, and the 2 stays the same, 2. So the vertex is 5, 2. I'm going to show you graphically how that looks. You can tell also that this graph went up 2 on the y-axis. It went up 2, and because of -5, right, it went 5 units to the right on the x-axis. So let's look at it graphically. So this is the parent graph right here, the light blue graph. So x minus 5 means that the graph goes to the right 5 units. So if you slide over 5 units on the x-axis, we're right here. And the 2 means that it went up 2 units, 1, 2. So that's the new vertex of the graph. As you can see now, the vertex is 5, 2, which is right here. So you got to change the sign, of the 5 when you write the vertex. All right. So today's lesson now, we're going to look at more of these examples, and we're going to use the T-Inspire calculator to do this. So if you have a calculator at home, you can follow along. I'm going to do another video using Desmos graphing for those that doesn't have the T-Inspire. All right. So let's bring up the T-Inspire calculator. So on the handout, the first graph is y equals x plus 4. Now, how do you get to this screen? Well, if you go to your home screen, all right, you're at your home screen right now, okay? You can press graph. Let me go back for a second. Press new. All right, press new. I'm going to click no. I don't want to save this. No. And then I'm going to add graphs, right, in there. Now, in the address box right here, all you're going to enter is the right side of the equation, which is x squared plus 4. So you don't enter y equals x plus 4. Just enter x plus 4. So first, I'm gonna plot the parent graph, which is x squared. So I'm gonna enter x, and then to get the square, I usually press this upside down V right here, and then 2. So that is the parent function, and I'm going to hit enter now. So that's the parent graph right there. Now I'm going to add the second graph, which is the transform graph, which is y equals x plus 4. To do that, go to tab, right? Because I'm going to add the second graph on this page right here. Go to tab, and you see the address bar appears again. Now F2 just means I'm plotting the second graph. So I'm going to enter x squared plus 4. X, upside down V, 2. Now the cursor is at the exponent, right? So I'm going to click anywhere in the address bar to get it down. Okay. And then plus 4. Now you see what you look at it now is the transform graph, right? It went from the parent graph 4 units up the y-axis. So this is the transform graph. And let me I can drag these around a little bit so you can see clearly what we're looking at. All right, right there. Okay. And I'm going to add. I'm going to look at this real quick. Pause the video. I'm going to ask some question. Does the new graph x squared plus 4, the red graph, does it have any x-intercepts? All right. And what is the domain? All right. Well, the answer is for this red graph, there's no domain. I'm sorry, there's no x-intercept because the graph does not cross the x-axis. All right. So remember, to get the let's say domain solutions are zeros. I'm sorry, the graph doesn't have any x-intercepts or zeros or solutions or roots. Same thing. Roots, solutions, zeros, x-intercepts are the same thing, because the graph does not cross x-axis, so there's none. Now, what does it look like if the graph crossed x-axis? Well, I'm going to shift I'm going to shift the parent graph down 4 units, right? And you're going to see what it looks like. So I'm going to add another graph. Let's go ahead and add x squared minus 4. So press the tab key. All right, now this is F3 means it's the third graph I'm adding right now. So I'm going to put x squared upside down V 2, and then to get the cursor down, press anywhere, and I'm going to put enter at -4. Then press enter. Now this is the third graph. As you can see now, this third graph, right, went down 4 units, and because it crosses the x-axis, right, it has zeros or solutions. Okay, so that's the big difference between the red and this graph right here. The domain is going to be, because the x values for this graph, right, just keeps on going all the way to the left. So the domain is going to be from -infinity to +infinity. Now look at the range. Okay, how do you know? Let's go to black graph. How do we find the range for the black graph? Well, if we have like a ruler and we slowly come up, right, on the y-axis, the point where we touch the graph, that's going to be the lowest point on the graph. So that's where the range is going to start. So that's -4 right there. And then if we keep on going up with a ruler, well, we'll never stop because the graph keeps on going. So the range is from -4 to +infinity. All right. Let's try a couple more. Okay, I think we did one and two on the handout. Let's go to um, let's do number 3. Okay, number 3 and number. Oh, one more thing I want to show you is how to um, get the tables where you have the x and y values. And so to do that, right, press Control T. So Control T, and T is for table, which is right there. Now, what you see now, the left column is the x values, right? It has negative values, and when x is 0, 1, 2. And this column right here is for the parent graph, x squared. And so these are the y values. Now, if you want to see the y values for the red graph, right, just scroll over. Um, okay, and this is the values for the red graph, x squared plus 4. And the other graph, the last one, the black one, is x minus 4. Now, one thing, and you can look at this, we can prove that that from the tables, right? I'm going to show you from tables that the black graph has these two x-intercept. Now, as you can see from the graph, right, the x-intercept on the right here is 2, 0, right? So at this point right here in the graph, the y value is 0. So if I look wherever there's a y, where the y value is 0, right? The corresponding x value is the x-intercept. So here we have 0 in the y column, and therefore x is -2. Okay. So if you give them a table and they ask you what is the x-intercept, just find the 0 values, right, in the y column and come over and you will find the x-intercept. The other x-intercept is 2. I'm sorry. This is okay. I was talking about this point, -2, 0. Sorry about that. So 2, 0, which is this point now, is right here. X is 2, y is 0. This one, the -2, 0, is this one. All right. I think you got the picture. All right. Let's go to try number 3 on the handout. It is x plus 5 squared. So what I'm going to do now, I'm going to open a new page, right? And to do that, press Control and the dot button right here. It's a plus page. And then we're going to add graphs. Okay. And this is a new page right now. You can still go back and forth. So I'm going to draw the parent graph first so we can see. So it's going to be x squared. And then hit enter. So that's the parent graph. To add another graph on the same page, right? I'm going to hit tab, and then I want to add x plus 5 squared, x plus 5 in parentheses square. So that I'm going to put the parentheses, x plus 5, close parentheses, and then square. Again, upside down V and 2, and I'm going to hit enter now. Okay, now you can see that the graph is a plus 5, so the graph shift to the left. All right, so now let's look at the vertex for the new graph. Okay, what do you think the new vertex is? Yes, it is -5, 0. All right, -5, 0. And so you can even look at what if you're given this equation, right? Um, you can find the vertex. Remember, it's HK, but in this case, K is 0. It's I don't add the 0 right here. So K is 0, and remember we got to change the sign of the 5, so it becomes -5. So the vertex is -5, 0. And the axis of symmetry, again, is the line that splits the graph in half and crosses the x-axis at -5. So the axis of symmetry is x equals -5. Okay. Okay. What do you think is the x-intercept? All right. If you said -5, that is correct. There's one. It touched the graph. It touched the x-axis at -5. Now we're going to look at the tables, and we're going to see the same thing, right? So I'm going to pull the tables. Look on the y column for where there's a 0, and you see -5 on the other side. So let's look at tables. Control T. Okay, so um, this right here is the x squared graph. And you can tell that the x-intercept for the parent graph, right, is 0. So if I look on the y column for 0, I should have 0 on the other side, on the x value. So let's find 0 in this graph right here. Look at that. When y is 0, right, x is 0, and that's it right here. Now let's find this, the x-intercept for the green graph. I should have 0 on the y column for this graph. So let's go. Let me scroll over to the next graph, which is x plus 5 squared. I'm going to find 0 in the y column. Let's see. 0 in the y column. I come over. -5 is my x-intercept. All right. Again, let me close this. And to close the table, right? Just press Control T again, and it goes away. Control T, and it goes away. Now let's look at the range for the green graph. Again, remember the range. I'm gonna approach from the bottom because that's what I want to find the lowest value. This might be if you have a ruler and you come up, I'm going to hit the graph at this point, and this point, right, the y value is 0. So that's my lowest point on the range. If I keep on going now, I will never stop, right, because the graph keeps on going. So it goes from 0 to positive infinity. Likewise, if I go from left to right with a ruler, okay, left to right, I hit the graph here, right? But if you notice now, the graph has an arrow on it. It just keeps on going. So really, it's from negative infinity to positive infinity. All right. So I'm not going to do that. So that's it for number 3. I'm not going to do number 4 because number 4 is very similar to number 3. I want to get to some of these. Let's look at number 5 on your handout. Number 5. Okay, I'm going to add a new page now. You remember to do that? Okay, so you press Control plus page, right? And then I'm going to add graphs. So that's my third page. So I'm going to enter my parent function, which is x squared. And then I'm going to enter. So that's my parent function. Now I'm going to add the transform graph. And so I'm going to hit tab now. And then it is parentheses x minus 4, shift x minus 4, square, x minus 4. Oh, I'm sorry. I got distracted for a second. Square. Now I need to get the cursor down. All right. So I'm just going to press anywhere here. And then it is plus 2. Okay. Oops. Oh, wrong answer. Wrong. Plus 2. Plus 2. All right. So that's what I'm looking for. Now, before I hit enter, can you tell where the graph's going to be before I hit enter? All right, just look at the x minus 4, see where it's going to go, right? And then the plus 2, right? And so let me hit that. So see that now? Uh, the colors are changing now. Let me slide this one over to the left. Oh, no, I need this one over here. This one I need to slide over to the, oops, I need to grab this one. Okay, I don't want to mess this up. I want to grab this one. Oh, that's not what I meant to do. Uh, oh, oh man, I want to get back to 1.8, 0.6. Mess this up. Okay, it should be 1. Okay, that's close enough. I was trying to grab the equation and slide it over, but it's not working. All right, so let's look at, is it going to change the value? I'm not sure. Okay, plus 4. All right. In fact, let me go back and try delete it then. Let me see if it will allow me to delete it, guys. Go back to tab and see if I go up F6, F7. Where's F7? Okay, it's not. All right. Okay, we'll see if okay. Let's go with that. All right. All right. Okay, this is the one I'm looking at. Okay, let's go back and this will be 1 right here. Let's go back and delete this. All right. Can I recover? There you go. All right. Now, as you can see, right, this is the parent function, right, and then this is the transform equation right here. And so x minus 4 means that the graph shifts 4 units to the right, right? 1, 2, 3, 4, and then the plus 2 means that the graph went up 2 units. 1, 2. All right. So you can see now just by looking at the equation, right, the vertex is going to be 4, positive 4, 2. Remember, you change the sign for the negative 4, 4, 2. So that's the vertex right there. And then the axis of symmetry, right, is going to be you draw a line through the equation and it splits in half. It's going to be x equals 4. It crosses the x-axis at 4. All right. Again, the domain. No, this graph now, as you can see, does not cross the x-axis. So do you think it's going to have solutions or zeros? No, it's not going to have because it does not cross the x-axis, right? So there are no solutions. What do you think the range is going to be? Okay, imagine if you got a ruler, right? And you go all the way up, all the way up. This is where the graph starts at, the y value. So that is 2. So that's the left part of your range. And then if you keep on going, the graph just keeps on going to positive infinity. So the domain is y greater or equal to 2 or 2 to positive infinity. All right. There's one more I want to do before the bell goes off for first period, and it's a challenge question, right? I'm going to put it in there real quick. Let's go. Tab plus new. Oh, that's not what I wanted. Oh, ooh. Should I press escape? Escape. Okay, here we go. I'm not sure what happened there. Control tab, uh, add graphs. And so I'm going to enter the function, which is parentheses x plus 6, I'm sorry, x plus 2, close parentheses, square, upside down v2, and then I'm going to click right here and put -6, all right? Now, I want you to tell me, okay, what would be the new equation for this function if it got shifted up 2 units? If I move this up 2 units, what would be the new equation? All right. Go ahead and pause the video and think about it. Now, if I went up 2 units, right? Therefore, this value is going to change. So if I go up 2 units, I'm going to move the vertex. I'm going to shift the graph up 2. 1, 2. What's my new k going to be? Right? It's going to be 4. All right. So this would become -4. So that's my new equation. Parentheses x plus 2 squared minus 4. All right. Again, I will do another video in Desmos for those that don't have the TI Inspire. All right.